Today shall be our last class before mid semester examination. Okay, so whatever we will be studying today, that will be the syllabus.
Good afternoon, sir.
Good afternoon, very good afternoon.
Good afternoon, sir.
Very good afternoon, very good afternoon. All right, so I had given a problem to you the last class. How many of you did try or attempted to solve that?
Yes, sir. Solved.
Solved?
Yes,
Yes,
sir.
sir.
Yes.
Very good, very good, very good. So other integrals can also be solved like that only. Okay, whatever way we have done so far. Once again, let me announce that the syllabus for the mid-semester examination shall be what I am teaching. I mean, up to what I am teaching today. I am going to teach today. Okay, that will be the syllabus. Understood?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
So
Yes, sir.
Yes, sir.
whole first unit and up to reduction formula. Okay, we are going to study reduction only today also. Okay, some more formula we are going to see. So up to that only we shall keep our syllabus limited to. So let's start now. So now let us start. So let us have and in let us we want to solve an integral of this form: sine to the power mx cos to the power nx dx. Okay, this is the form of an integral, and m and n are positive. Okay, here m and n are positive. That is what uh, it is, and I am trying to solve this particular or reduce this particular integral. Now here there are two exponents, m and n. So I will write down it as I m and n, means this integral is with the m and n powers. Okay, that is the simple meaning of it. This is our notation, let us say. Okay, so I can write down sine to the power m minus 1x sin x cos to the power nx dx. All right, this can also be written as sine to the power m minus 1x d minus cos to the power n plus 1x by n plus 1. Okay, sine to the power m minus 1x, and this whole thing I can club under this derivative. Can I do that? Because you can simply see that if I differentiate it, what I will get? N plus 1 cos to the power nx sin x, and minus minus will cancel out. So n plus 1 will also cancel out. So we will get exactly this. I hope it is clear to you all.
Yes, sir.
Yes, sir.
All right. So now what next should we do? Once again, we shall apply our formula. This one, u dv is equal to uv minus v du. That is, we will integrate by integrate this integral by parts. Okay, that is what we are going to do. So once we do that, can you tell me what are the terms we are going to get? We will be getting u means sine to the power m minus 1x multiplied by minus cos to the power n plus 1x by n plus 1. Is it okay? अरे भाई बोलो तो.
Yes, sir.
Yes, sir.
जो मैं पढ़ा रहा हूँ समझ में नहीं आ रहा है किसी को?
आ
Sir,
रहा है।
आ रहा है?
आ रहा
आ रहा
है
है।
सर।
आ रहा है तो प्लीज कंट्रीब्यूट. ओके, और नहीं आ रहा है तो भी पूछो. प्लस और माइनस क्या है ये? माइनस कॉस टू द पावर n प्लस 1 x बाई n प्लस 1 इंटू क्या आएगा? साइन टू द पावर m माइनस मीन्स का डिफरेंशिएशन क्या होगा? m माइनस 1 साइन टू द पावर m माइनस 2x. ओके, और इसका sin x का
Cos x.
डिफरेंशिएशन क्या होगा?
Cos x.
Cos x.
dx. Can I write down it like this? So I can write down it like this: minus sine to the power m minus 1x cos n plus 1x by n plus 1 plus integration of अच्छा m minus 1 भी तो है यहाँ पर. So I can write down this m minus 1 and by n plus 1. That I can take out of this. So I can write down it as cos n plus 1 x sin m minus 2x cos x dx. ठीक है? Can I write down it like this? So
Yes,
sin
sir.
m minus 1x cos n plus 1x by n plus 1 plus m minus 1 by n plus 1 cos to the power nx multiplied by cos x. ठीक है ना? Into sin to the power m minus 2x. So यहाँ एक cos x है और एक यहाँ cos x है. What we will going multiplication of them will yield cos square x,
Cos square.
right? So confusion की कोई जरूरत नहीं है. We have brought cos यहाँ से लेकर के आए हैं हम. एक cos x यहाँ से उठा लाए. ठीक है?
Yes, sir.
Okay. So minus sine to the power m minus 1x cos n plus 1x by n plus 1 plus m minus 1 by n plus 1 cos to the power nx sine m minus 2x, and this can be written as 1 minus sine square x dx. Can I write?
Yes, sir.
All right. So we can write down like this. Okay. So let us solve it further. So minus sine to the power m minus 1x cos to the power n plus 1x by n plus 1 plus m minus 1 by n plus 1 into cos to the power nx sine to the power m minus 2x dx minus m minus 1 by n plus 1 into cos to the power nx, and this will be sine to the power mx dx. Can I write down it like this? ये multiply होने से sin square x से that will become sine to the power mx.
Yes, sir.
All right. So this is once again the same integral which we started with, isn't it?
Yes, sir.
So I can bring this whole thing on this side. Okay. I can bring this whole thing on this side. So
Yes, sir.
what? Huh? So I mn into 1 plus m minus 1 by n plus 1 is equal to minus sine m minus 1x cos n plus 1x by n plus 1 plus m minus 1 by n plus 1 cos to the power nx sine m minus 2x dx. Is it okay?
Yes, sir.
Yes, sir.
And then we can see that this n plus 1 will also cancel out. And
Yes, sir.
here 1 and 1 will cancel out. What will be left over here with m plus n. So that will be divided. And so I can write down I is equal to minus sine m minus 1x cos n plus 1x by m plus n plus m minus 1 by m plus n cos to the power nx sine m minus 2x dx. So this is 1. Okay, this is not 1 I am writing because this is equation number 1. I am writing that this is form 1. इसका इस फॉर्मूले का एक रूप ये है. This is one of the form of the formula, and multiple formula we can deduce for the same thing. For the same thing we can express in different ways, and that actually can be useful when we solve the problems, because out of all these forms we can pick up a particular form which will be more useful for solving a problem. Means easily we can solve using that. So accordingly we will choose a formula. So this is one of the form of this one. We can express it in this way also. Everybody has written like this one. You can actually box it. You can put it in box. All right.
Yes, sir.
Yes, sir.
Then we can have the same thing. We can write down it like this also. See, you will say that, sir, why did you consider sine to the power m minus 2x sine to the power sine to the power m minus 1x into sine x cos to the power nx dx? Why did I you consider it like this? Cos to the power n minus 1x cos x sine to the power mx mx dx. We can write down it like this also. When we will solve this, and that will not be incorrect, that is perfectly all right, right? So I can now solve this. So when I try to solve it, I can write down it like this: cos to the power n minus 1x, and this whole thing can be written as d sine m plus 1 x by m plus 1. Okay. Now once again let us integrate by parts. So what shall we get? Sine m plus 1 x into cos to the power n minus 1x by m plus 1.
Yes, sir.
Right? And what will be the further things? Sine m to the power m plus 1x by m plus 1 into differentiation of this means n minus 1 cos to the power n minus 2x into minus sin x dx. Am I right? Am I right?
Yes, sir.
All right. So if
Yes,
you
sir.
solve it, now you know how to solve it further. Once again, we will find out a form where we can arrive at this IMN form on this side, so that we will bring on this side, and so on and so forth. So the final outcome will be, I am writing down final outcome. Okay. I am writing final outcome. And what is that final outcome? That final outcome is equal to this one, sine m plus 1x cos to the power n minus 1x by m plus n plus n minus 1 by m plus n into sine to the power nx cos to the power m minus 2x dx. This is another form. I hope it is clear. The rest of the things you will solve by yourself. कर लोगे ना वो
Yes.
काम तो?
हाँ हो जाएगा।
ठीक है ना, बाद में ये आएगा sin x आएगा ना यहाँ पर, तो एक sin x उठा करके यहाँ से sin स्क्वायर x बना देना, और sin स्क्वायर x को हम में 1 माइनस cos स्क्वायर x लिख सकते हैं. ठीक है,
Yes, sir.
और बाकी तुम सॉल्व कर
Yes,
लेना.
sir.
आई थिंक सब हो जाएगा. सो दिस इज अनदर फॉर्म. अब यही दो फॉर्म नहीं है, वी कैन राइट डाउन इन मेनी अदर फॉर्म्स आल्सो. Okay, many other forms. So another form of this one is which you can yourself derive. I will not help in deriving those things. Next is sine to the power mx cos to the power nx dx can be written like this also. Sine to the power m plus 1 x cos to the power n minus 1x by m plus 1 plus n minus 1 by m plus 1 sine to the power m plus 2x cos to the power n plus n minus 2x dx. This is third. Okay, this is third form. I hope it is clear.
Yes sir.
Yes.
Yes, sir.
All right. Shall I omit this one?
Yes sir.
All right. Other forms are also there are other forms as well. So we got 3. We can find out this also. So this particular formula which we have written in this form, it is useful when m is, it is more useful. I mean, you can use other formula also. It is not that you cannot use other forms, but this is much more useful when m is negative integer and n is positive integer. All right, it is more useful when m is negative integer and n is a positive integer. Okay, then we can have another form also. We can have this kind of form, that sine left hand side you write down yourself. Okay, so this formula can also be written as minus sine to the power m plus 1x cos to the power n plus 1x by n plus 1 plus m plus n plus 2 by n plus 1 sine to the power mx cos to the power n plus 2x dx. This is another form. Okay, this is another form. Can you see it properly on the board?
Yes sir.
Okay, now this formula is useful when n is negative number. Okay, this form is useful when n is negative number. So for example, I'll just take an example that how we can actually use different forms of the same I mean, for the same integral, different forms of the formula, okay, we can use uh, in the problem, and we can simplify, I mean, simplify the problem. So, for example, use of this particular formula for, I mean, this form of the formula. So, suppose we have been given a problem that we have to evaluate sine square x cos cube x dx. The limit goes from 0 to pi by 4. Okay. So now here m is equal to 2 and n is equal to -3. I can bring in the numerator, and you can see it is -3. Okay. So this particular thing will become, I can write down 0 to pi by 4 sine square x cos to the power -3x dx. Now this will become minus sine cube x cos to the power -2x by -2. Okay. Plus 1 by -2. Okay. N is -3 na. So -3 plus 1, -3 plus 1 into sine to the power mx means sine m is 2, and cos means cos to the power -1.
-1x dx.
Okay. Is it okay?
Yes,
We
sir.
have utilized this particular form. So now we can simplify. What is the use of this formula? That's just to simplify the problems. Okay. How simply or how easily we can carry out a problem, or we can solve a problem. Okay. So 1 by 2 3 sine 1 by 2, not 1 by 3. Yeah. 1 by 2 sine cube x by cos square x minus 1 by 2, and this can be written as 1 minus cos square x by cos x dx. Can I write down it like this thing? Can
Yes,
I
sir.
or can I not?
Yes, sir.
Yes, sir.
All right, I can write down. So 1 by 2 sine cube x cos by cos square x minus 1 by 2 sec x minus 1 by 2 cos x dx. Can I write down it like this? Can I write down?
Yes, sir.
Yes, sir.
All right. So this can be written as this can be written as 1 by 2 sine cube x by cos square x, okay, minus 1 इसका क्या होगा sec x dx का इंटीग्रेशन 1 by 2
tan x.
log sec x plus 10x. पढ़ा है ना ये तो,
Yes, sir. हाँ.
राइट, प्लस इसका क्या होगा 1 by 2 sin x. ये तो सिंपल है. Is it or not?
Yes, sir.
All right. So once we have got this, then this can be written as I can bring alongside this. So 1 by 2 common, sin x common. So this will be sin square x by cos square x plus 1 minus 1 by 2 log sec x plus 10x. Is it okay? So this can be written as 1 by 2 sec x 10x. Can I write down it like this? Can I write down it like this? This will be sin x by cos square x.
Yes, sir.
So that can easily be written like this. minus 1 by 2 log sec x plus 10x. And so if I put limit to this, I will get 1 by 2 square root of 2 minus 1 by 2 log square root of 2 plus 1 minus log square root of 2. So this is what the solution of that problem is. All right. Now
Yes, sir.
there are other forms as well. There are other forms as well. Has everybody written down this? Noted down?
Yes,
Yes,
sir.
Yes, sir.
Yes, sir.
Then sin m to the power mx cos to the power nx dx is equal to sin m plus 1 cos to the power n plus 1x by m plus 1 plus m plus n plus 2 by m plus 1 into sin m plus 2x into cos to the power nx dx. This is another form. This is, let us say, fifth form. For the same formula, you see, for the same integral, we are obtaining different types of formula, different forms actually are there. And one more form we can find out, that is minus sine m to the power m minus 1x cos to the power n plus 1x by n plus 1 plus m minus 1 by n plus 1 into sine m plus 2 x into cos n plus 2x dx. This is another form. So this is one form and this is another form.
Sir, in form fifth, what is sine m plus 2 or sine for m plus 3x?
This is sine n plus 2. M plus 2 and n plus 2.
Sir, in fifth form,
In fifth form, it is sine m plus 2x into cos to the power nx dx.
Okay, sir, got it.
हाँ yes.
सर इन फिफ्थ फॉर्म वो जो साइन फर्स्ट में लिखे साइन m
n
प्लस
plus
1 है
1
कि
और
2
cos n plus 1 दोनों n, ये
ठीक
m plus 1 है और ये n plus 1 है. ठीक है.
यस सर
All right. तो अभी इसी से रिलेटेड है कि हमारे पास एक इंटीग्रेशन है. वी हैव टू इंटीग्रेट समथिंग sin m to the power nx cos
सर
to the power nx. हाँ बोलो बोलो
सर
बोलो.
थोड़ा नीचे लिखिए वहां पे लाइट पड़ रहा है तो दिख नहीं रहा है
अच्छा अच्छा. एक्चुअली क्या है, बोर्ड छोटा हो गया है. एक मिनट, मैं लाइट ही ऑफ कर देता हूँ इधर की, अपने आप दिखेगा. जस्ट मिनट.
हाँ ठीक है सर
Yes, sir.
अब क्लियर है?
यस सर
Yes, sir.
Yes, sir.
अंडरस्टूड. एक्चुअली वो थोड़ा ग्लेयर वो कर रहा है. तो अब हमको निकालना है, इसको इवेल्युएट करना है इस इंटीग्रल को. तो लेट अस कंसीडर दैट दिस इज I, right? Or now let us use form 1. Okay, let us use form 1. So from that, I mean, you can use other forms also. There is no harm in doing that. But yes, let us take first form. and so I can write down it as minus sine m minus 1x cos to the power n plus 1x by m plus n 0 to pi by 2 is the limit, plus m minus 1 by m plus n 0 to pi by 2 sine to the power m minus 2x cos to the power nx dx. This integration will this will vanish, this term, this will become 0. ओके क्योंकि साइन पाई बाई 2 रखेंगे, सॉरी कॉस पाई बाई 2 रखेंगे तो 0 होगा, और साइन 0 रखेंगे तो 0 होगा, राइट? तो बिकॉज देयर इज अ मल्टीपल ऑफ दिस, तो एक फाइनाइट रहने से भी दूसरा 0 ही होगा. ओके, सो मल्टीप्ल इन ऑल उनका मल्टीप्लिकेशन 0 ही आएगा. ओके, सो दैट इज वन थिंग. सो व्हाट वी आर गोइंग टू गेट, सो यहाँ पर हमने देखा कि यदि हम इसकी इनिशियल पावर m है और n पावर है, तो we will get m minus 1 by m plus 1 0 to pi by 2 sine to the power m minus 2x cos nx dx, यानी कि पावर यहाँ पर m की 2 से रिड्यूस हो गई. तो इसको हम इस पूरे को लिख देते हैं I m minus 2 n. इसकी पावर तो n ही है, साइन की पावर m minus 2 हो गई. I hope it is clear.
Yes, sir.
So
Yes.
the whole thing we can write down like this: I m minus 2 n. So now you just see कि जब m होता है तो यहां पर इंटीग्रेशन रिड्यूस होके क्या बन जाता है, पावर उसकी क्या हो जाती है, m minus 2, m की पावर, राइट? सो समझ में आ रहा है ना?
Yes,
Yes,
sir.
sir.
Yes, sir.
तो नेक्स्ट क्या होगा जब हम इसको यूज करते हैं, हम यूज करते हैं कि सिमिलरली वी यूज रिकरेंस रिलेशन है. ओके, व्हाट दिस रिकरेंस रिलेशन विल टेल मी दैट जब ये i m minus 2 है ये, तो क्या होना चाहिए, दिस शुड बी m minus, क्या आना चाहिए, m minus
M minus 3.
ओके, बाई m प्लस n है एक्चुअली, सॉरी m प्लस 2 कहां से गलती से लिखा, m प्लस n, राइट? सो दिस विल बी m माइनस, नीचे क्या आएगा,
M
हम
plus
तो-
n minus 2.
हाँ, m plus n minus 2, correct. We have to now put in place of m, we will put m minus 2. Okay, so this will be I m
M minus 4.
4n. Next I m minus 4n. बताओ m minus, what should I write down?
M minus 5.
Correct, m minus 5 by m plus n minus 4
4.
I m minus 6n. Okay, so if I continue like this, then I 3n will be equal to 2 by 3 plus n I 1. Okay, when m is odd. All right, and that will be 2n when it is 1 by 2 plus n, when m is even. All right, is it or not? Arey,
Yes,
is it
sir.
or not?
Yes, sir.
All right, so this is what we shall be getting. So so now we have to find out these values, 1n and 0n, right? So let us find out that also. So I 1n will be equal to 0 to pi by 2 यानी कि sin to the power 1 means sin x and cos to the power nx dx. Is it or not?
Yes, sir.
So this will come out to be equal to minus cos to the power n plus 1x by n plus 1 0 to pi by 2. When we solve it, we will get this and this will be equal to 1 by n plus 1. Fine. ये तो हमारे पास फॉर्मूला है ना इसका, तो sin x cos to the power nx dx का हमने निकाले ना अभी फॉर्मूला,
Yes, sir.
राइट? उसमें किसी फॉर्मूला में डाल देंगे हम, ये मिल जाएगा हमको, राइट? एंड m इक्वल टू 1 और n is equal to n, right? That is what the thing is. और I 0 n, what it will be? It will be 0 to pi by 2 cos to the power nx dx. Is it okay? Which can be written as 1 by n sin x cos to the power n minus 1x plus n minus 1 by n cos to the power n minus 2x dx, and this is from 0 to pi by 2 and this is from 0 to pi by 2, right? So once again this will become 0 and only thing will be left is n minus 1 by n 0 to pi by 2 cos to the power n minus 2x dx. Okay, and we can solve it and we know what will be the answer. So now we will have certain answers. So first of all, if m is odd and n is even or odd, whatever the way, according to Wallis formula, we will get this thing. We can use it, and not Wallis formula, sorry, the formula which we just recurrence relation, Wallis formula, recurrence relation, which we found out when we put all those values. So the first value will be m minus 1 by m plus n into m minus 3 by m plus n minus 2 into m minus 5 by m plus n minus 4 and so on and so forth, 2 by 3 plus n into 1 by 1 plus n. So this is the formula which we will get. Is it visible or not?
Yes, sir.
Yes, sir.
Okay. So this
Sir,
is
last
what
line is
Sir, what is written second last term?
here. This one.
no, sir,
Sir,
last line.
2 upon
2 upon 3 plus n. Just now हमने देखा था ना 2 by 3 plus n, है?
Yes, sir.
yes sir.
हाँ,
Yes,
and
sir.
into 1 by 1 plus n, ये वाला, नहीं? ये किस केस में होगा? जब m is odd and n is even or odd. Okay?
Yes, sir.
और जब सेकेंड है, जब m भी इवन है और n भी इवन है. ओके, तो इन दोनों केसेस में जो होगा ये होगा m minus 1 into m minus 3 into m minus 5 into divided by m plus n into m plus n minus 2 into n plus 2 into n minus 1 by n into n by n minus 3 by n minus 2 into 1 by 2 into pi by 2. ये जो लास्ट वाला फॉर्मूला है ये तभी एप्लीकेबल होगा जब दोनों इवन होंगे, m भी इवन होगा और n भी इवन होगा. क्लियर हुआ?
Yes, sir.
राइट? इसका हम ऑलरेडी बैकग्राउंड तो सब हम देख ही चुके हैं। वालिस फार्मूला हमने निकाला था ना पहले, इफ यू रिकॉल।
Yes, sir.
So there we have seen all this. So this is what we will get. यहां तक सबको समझ में आ गया?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right. Can I omit it?
Yes,
Omit
sir.
कर दें?
सर
हाँ बोलो।
सर अगर ऐसा इंटीग्रल आया कहीं पे भी तो डायरेक्ट फॉर्मूला यूज कर देंगे
और तो क्या,
या प्रूफ करना पड़ेगा
किसको?
ये फॉर्मूले को?
नहीं, प्रूफ थोड़ी करना है। यदि इस फॉर्मूला का यूज करके देखो, ये तो डिपेंड करता है तुमको कितना बड़ा सवाल है।
सिंपल मतलब साइन पावर कुछ
यदि आप
m
दो नंबर का सवाल है तो उसके लिए तो पूरा करने की जरूरत नहीं है।
अच्छा
पर यदि 10 नंबर का सवाल है तो राइट।
फिर प्रूफ करेंगे सर।
चलो अब इसकी कुछ कोरोलरीज हैं। तो इसके क्या क्या कोरोलरीज हैं कि मान लो कोई इंटीग्रेशन ऐसा हो कि जो दिख नहीं रहा है, जैसे हमने पहले देखा था कि उसका अपेरेंटली ऐसा नहीं दिख रहा था कि इसको इस फॉर्म में लाया जा सकता है। ठीक है,
Yes, sir.
इसको सॉल्व करने के लिए तो देयर आर सर्टेन इंटीग्रल्स। फॉर एग्जांपल एक इंटीग्रल है इस तरीके का, मान लो 0 to 2a x to the power m square root of 2ax minus x square. Okay, this is what your integral is. Okay. इसको हमको सॉल्व करना है तो हम इसको इजीली इस फॉर्म में ला सकते हैं, जो कि हम ऑलरेडी जिसका फॉर्मूला हमने अभी डिड्यूस किया है, राइट। तो कैसे ला सकते हैं कि सपोज करो कि वी लेट अस पुट x इज इक्वल टू 2a sin स्क्वायर थीटा, ये हमने डाल दिया इसके में। तो व्हेन वी पुट दिस व्हाट वी आर गोइंग टू गेट, we are going to get x to the power m plus half 0 to of course 2a sorry 0 to pi by 2 होगा ना, 0 to pi by 2, so 2a no, 2a to the power m plus 1 by 2 into sine to the power 2m plus 1 theta into root 2a into cos theta into 4a sin theta cos theta d theta, and finally हम इसको सॉल्व करेंगे तो we will get 2a to the power m plus 2 into 2 to 0 to pi by 2 sine to the power 2m plus 2 theta into cos square theta d theta। अब ये उसी फॉर्म में आ गया ना, sin to the power m theta और cos to the power n theta, is it or not?
Yes, sir.
जहां पर m की जगह पर हमको क्या रखना पड़ेगा?
2m plus 2.
बस
2m.
करेक्ट, 2m plus 2, that's all, और n की जगह पर 2,
2,
right?
sir.
So it has, we have brought this into this form. So ये integration once we bring into this form, this already we know how we can solve it. So this is one. Another form, मान लो हमारे पास ये इंटीग्रेशन इस तरीके का है 0 to infinity x to the power n dx by a square plus x square to the power n। ठीक है, तो x इज इक्वल टू है 8 tan थीटा, राइट, राइट और रॉन्ग?
Yes, sir.
राइट, तो dx क्या हो जाएगा? a sec स्क्वायर थीटा डी थीटा, सब इसमें पुट कर देते हैं हम। हाँ, ये सब पुट कर देते हैं। सो फाइनली हमारे पास जो फॉर्म बचेगा वो होगा a to the power 2n minus 2m plus 1, 0 to pi by 2 is the limit, sine to the power n theta cos to the power 2m minus n minus 2 theta d theta. Okay, so in this form we have brought it. We can solve it. This one also we can solve it. ठीक है? So this whole thing we have brought it into this. आप बाकी जो intermediate steps हैं, that you see yourself. That is your problem. Okay. And next is that if suppose I am having this kind of form, x to the power n dx by a square plus x square to the power m plus 1 by 2. So in this case also we put x equal to a tan theta, and when you solve it, then finally you will get a to the power n minus 2m into the limit 0 to pi by 2 sine to the power n theta cos to the power 2m minus n minus 1 theta. So once again we have brought in that form. Now here m is equal to n and n is equal to 2m minus n minus 1. ठीक है?
Yes, sir.
All right, so we can easily solve it. So point is that these kind of integrations can be solved. In addition to this, so यहाँ तक समझ में आ गया सबको?
Yes, sir.
Yes, sir.
Yes, sir.
Now, in addition to this, we can actually evaluate this integral sine to the power m x cos to the power nx dx can be evaluated like this also. Okay, but under certain conditions, है ना, वो याद रखना. Those conditions are that suppose m is, if m is odd, then put cos x is equal to t. All right, then put cos x is equal to t. Secondly, if n is odd, पहले हमने माना है m odd है, अब हम मान रहे हैं n odd है, तो then in that case you put sin x is equal to t. Condition है, right? In this case you can do it that you can put cos x equal to t provided m is odd. If n is odd, then you can put sin x is equal to 2 and easily you can reduce this integral. Okay, third is that if m plus n, if I add these two terms, power, sorry, then these two powers, if this powers is negative, okay, integer, then in that case put tan x is equal to t. So when you put tan x equal to t, you can solve it, provided the powers are negative integer. Then
Yes, sir.
right, then fourth thing, I think I should write over here. Then fourth thing is that if both m and n are even integers, okay, are even integers, Then number A, that if m and n are small, then in that case you can use this kind of formula: cos square x is equal to 1 plus cos 2x by 2, sin square x is equal to 1 minus cos x cos 2x by 2, and sin x cos x is equal to sin 2x by 2. This kind of formula you can use, okay, when m and n are small. But if m and n are large, तब हम क्या करेंगे? We will use de Moivre's theorem. Okay, we will use de Moivre's theorem, and then in that case we will put z is equal to cos x plus I sin x, and 2 cos x is equal to z plus 1 by z. ये पहले हम निकाल चुके हैं, निकाला था ना
Yes,
हमने?
sir. Yes, sir.
Right?
पिछले क्लास में.
हाँ, पिछले क्लास में. और 2i sin x is equal to z minus 1 by z, और फिर इसी तरीके से to the power n and cos nx और sin nx लेकर के we can find out. Okay, so we can, this is how we can find out the different formula. So there are alternative ways depending upon if, for example, m is even, m is odd, or m and n are even and odd. Accordingly, we can make out our way to simplify the process. This whole thing is that alternative processes means you can have a process or a way in which you can solve the problem, but it will take more time. And there may be some other alternative ways where you can solve the problem in much lesser time. So that is what we have to choose. Okay, so I hope it is clear.
Yes, sir.
Yes, sir.
All right. So all the best for your midterm examinations. All right, now you start preparing for that. I will not take any class till your examinations are over. I think your examinations are getting over by 9.
9,
Yes,
yes, sir.
sir.
9.
Yes.
From 10 onwards we shall once again engage the classes. I hope अभी तक जो पढ़ाया है समझ में आया है सबको?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
All
Yes,
right.
sir.
अच्छी तरीके से?
Sir,
Yes, sir.
कोई क्लास नहीं है ना सर एग्जाम से पहले.
क्या?
सर कोई भी क्लास नहीं है ना मैथ्स की.
मैंने बोला ना 10th को मैं लूंगा क्लास नेक्स्ट.
ओके सर.
ओके, सिलेबस जो है यूनिट 1 और जो है मैंने आज जो मतलब रिडक्शन फॉर्मूला पूरा जो भी मैंने पढ़ाया है ये सब, ठीक है. एंड दिस इज नॉट लिमिटेड टू दिस वन की जो मैंने पढ़ा दिया बस इतना ही, मतलब इससे रिलेटेड जो भी प्रॉब्लम्स हैं. आई होप इट इज क्लियर.
Yes, sir.
Yes, sir.
ओके, एनीथिंग यू वांट टू आस्क?
Yes, sir. सर एग्जाम में प्रूफ भी आ सकता है.
आप कुछ भी आ सकता है, मैं क्यों बताऊं क्या आ सकता है. एग्जाम का मतलब ही होता है कि इट इज काइंड ऑफ एग्जाम. आपने क्या समझा है उसके लिए है ये, ठीक है. और जो हमने पढ़ाया है उसी में से आएगा. ऐसा नहीं है कि हम उससे कहीं बाहर से लेकर के आ रहे हैं चीजों को, ठीक है.
ओके सर.
Thank you, sir.
ओके.
Thank you, sir.
ओके.
Thank you, sir.
Thank you, sir.